Hello everyone. Today I, Asif Kamal, a student of SVC Sri Venkateshwara College of Engineering, is going to talk about a topic related to finding volume by triple integration and center of gravity. So let's start. Introduction. We are going to talk about these three topics: volume by triple integration and center of gravity, understanding the concept of volume and its calculation, importance of finding the center of gravity. So first, volume by triple integration. Triple integration is a method used to calculate the volume of irregular shapes. Involves integrating a function over three dimensions x, y, and z. Triple integration allows for calculation of volume in both Cartesian and cylindrical coordinate system. As we can see, the irregular shapes means 3D shapes, and because we are finding a volume of a 3D shape, so we need three dimensions x, y, z, and triple integration allows for calculation of volume in both the systems, Cartesian system and cylindrical coordinate system. So moving ahead, calculating volume with triple integration. Step 1, determine the limits of integration for each variable. So step 1, we have to determine the limits of x, y, z before starting the calculation. Step 2, set up the integral using appropriate coordinate system. Step 2 is where we need to find the appropriate coordinate system for our calculation. Step 2, set up the integral using the appropriate coordinate system. So previously we saw that we can use Cartesian or cylindrical coordinate systems. So among them we have to choose one to solve the question according to our need. Step 3, integrate the function over the specified limits. So as in step 1 we specified the limits, now we have to integrate the function over the specified limits. Moving ahead, example of calculating volume. Consider a solid bounded by the planes z equal to 0, x equal to 0, y equal to 0, x plus y equal to 1, and z equal to x plus y. So here, as we can see, we have specified the lower limit is z equal to 0, x equal to 0, y equal to 0, and then we specified that x plus y equal to 1 and z equal to x plus y. So from this we can say these are our limits. So now to set up the integral using appropriate limits for each variable. So here the variables are x, y, and z. Now we have to set the triple integration for each variable here. Integrate the function over the specified limit. After setting up the integral, now we have to integrate over the specified limits. Moving ahead, center of gravity. The center of gravity is the point where the entire weight of an object can be considered to act, also known as the centroid or center of mass. Important for understanding the stability and equilibrium of an object. As you can see in the right side, here are the center of gravity and formula for center of gravity for some shapes. Calculating center of gravity. For continuous object, the center of gravity can be found using triple integration, similar to calculating the volume, but with an additional weight factor included. Integration is done over the entire object to determine the weighted average position. So from this we can say that the continuous objects, for a continuous object, the center of gravity can be found using triple integration. Means continuous objects means a regular object with the surface with the continuous distribution of mass and shape. We can find the center of gravity using triple integration. similar to calculating the volume, but with an additional weight factor included. It is similar to find the volume, but additional weight factor is included. Integration is done over the entire object to determine the weighted average position. The integration is done for whole shape to determine the weighted average position. Now moving ahead, importance of center of gravity helps determine the stability and balance of objects, useful in engineering, architecture and other fields, essential for calculating moments and forces acting on objects. Here are three applications of finding the center of gravity. When we find the center of gravity, we can understand the stability and the balance of an object, and it is useful for different types of fields, and we can find the movement and forces acting on the object. Now, example of calculating center of gravity. Consider a thin plate with varying mass density. Set up the triple integral using appropriate limits for each variable. After considering a thin plate with varying mass density, set up a triple integration uh, with appropriate limits, the limits for x, y, and z, and set up a triple integral for that. Include the weight factor in the integrand to find the center of gravity. Now, applications of volume and center of gravity. In architecture, determining the weight distribution of structures. In engineering, it is used to design the stable structures and machinery. In physics, we analyze the stability of objects in motion. Moving ahead, conclusion. Volume by triple integration and center of gravity are important concepts for mathematics and physics. They allow for calculation of volume and the determination of the weighted average position. Understanding these concepts is crucial in various fields, including engineering and physics. So that's all from my side. Thank you for watching. Please like, share, and subscribe.